Hello and welcome to another lesson on GCSE physics. Today's learning intention is to understand changes of state. Now for the Do It Now task, I would like you to consider the following question: why do we add salt to roads in icy conditions? Pause the video, write down your answer to the question and then we can discuss it. Okay, so the question was, why do we add salt to the roads in icy conditions? Well, the answer to that is going to become clear as we go on to the first slide of today's lesson. The success criteria for today's lesson is to describe the difference between boiling and evaporation, to know why changes of state are physical changes and not chemical changes, and to explain what happens to the particles in a substance when a change of state happens. So, the melting point and boiling point of substances are affected by impurities in the substances. The melting point of water gets lowered if it contains salt. Therefore, when we add salt to the roads, any water that is on the road is going to have the salt dissolved into it. That means that the melting point of that water, or ice as it will turn into, is going to be lowered, and so therefore the water will stay frozen for less time, I suppose you could say, or the temperature doesn't need to rise as high in order to melt the water or melt the ice. So, 6-mark question I'd like you to have a go at, please. It sort of takes into account what we've already done in a previous lesson as well. I want you to have a go at explaining what happens to the particles when a gas changes into a liquid. Use your knowledge from the previous lesson, please. Pause the video to write your answer, and then we will go over the answers. So, the particles will move slower when a gas turns into a liquid. Or you could have phrased that by saying the particles in a liquid move more slowly than the particles in a gas. The second mark is for saying that is because they have got less kinetic energy. The particles will also move closer together and will then touch each other. Or you could say the particles in a liquid touch each other, but in a gas they didn't. That is because the forces of attraction between the particles are stronger in a liquid than they are in a gas. And then finally, for the 5th mark, you can say the particles will collide with other particles more often, 6th mark, and so that means they will change direction more often when they are a liquid. Okay, similar drill, 4 marks. I want you to explain what happens to the particles when a liquid changes into a solid. Pause the video and write down your answers. So, when a liquid turns into a solid, the particles will no longer move freely. Instead, they will vibrate about fixed positions. They are 2 separate marks. We can then say the particles will be in a regular arrangement instead of an irregular arrangement. That is because the forces of attraction between the particles are much stronger. Okay, what we have here is a graph that shows how the temperature of a substance, you could think of it as being ice if you want to, changes as it is heated up. So we're heating ice over a period of time and we can see what happens to it. What I would like you to do for me, please, is write down A, B, C and D and then say what is happening at each stage, A, B, C and D. Then, if possible, I want you to write an explanation for why the temperature doesn't change at B and D. So, at point A, we can see that the temperature is increasing. It increases from -20 to 0 degrees. Then at point B, we have the melting process happen. If this is ice, ice melts at 0 degrees C. It turns into a liquid. At part C, the temperature is increasing again. You could say the temperature increases at a constant rate. That would also be more detail. At part D, you can say that boiling happens. It wouldn't be evaporation because we've reached the boiling point of water at 100 degrees, so D is boiling. Or you could have said instead that the liquid changes into a gas. That would also have been fine. And then at part E, we can say that the temperature increases at a steady rate again. Now the temperature doesn't increase at positions B or D because the energy being provided when it's being heated is being used to break bonds between the particles. That is why the temperature doesn't change when there is a change of state. For any substance when it's being heated up, its temperature stays constant whilst it is changing state. We've just seen that in the previous example, that when that ice was melting, it stayed at 0 degrees until it had fully melted, and likewise, the liquid stayed at 100 degrees until it had fully boiled. Changes of state are physical changes, not chemical changes, because the material will recover its original properties if the change is reversed. Now let's consider the key differences between evaporation and boiling. We've touched on these in the previous lesson anyway, but let's go into them in more detail. Evaporation will only happen at the surface of the liquid, so the particles on the very surface are the ones that will escape. The ones deeper into the liquid wouldn't escape from the liquid. However, in boiling, the particles can escape from throughout the liquid, and so we can say that boiling happens throughout the liquid. Evaporation happens at any temperature that is lower than the boiling point, whereas boiling only happens at a specific temperature known as the boiling point. Evaporation is a very slow process, whereas comparatively boiling is a very fast process. Right, I'd like to have a go at these exam questions for me now, please. There's 3 questions in total. Read through the questions and pause the video to answer them, and then I will talk you through the answers to each one. Question 1. A student has some stearic acid. It is in a solid state. The student uses the above apparatus to measure the boiling point of some stearic acid. He records the temperature of the stearic acid every minute, and we've been asked to design a results table for the student to record his results in. Now, the key things to remember with results tables are that we have to clearly label the headings of the table. You're not required to introduce any estimated values or anything like that. We just need a blank table to record our results in. Now, obviously, he's recording the temperature, so we need to have temperature as one of the column headings, and it says that he does this every minute, so we need to have time as the other column heading. We also need to make sure we include units in the column headings, so we should have temperature brackets degrees Celsius, and we should have time brackets seconds. The mark scheme would accept time brackets minutes as well. Part B. The student then draws a graph of his results, which is shown below. What is the melting point of stearic acid? Well, the melting point is going to be the point where the temperature remains constant, because during a change of state, the temperature doesn't change. So we can see here, looking closely at the graph, that here the temperature is remaining constant, and that is happening at 70 degrees. So the melting point of stearic acid is 70 degrees C. The student decides to repeat their investigation. Explain why it is always advisable to repeat a scientific investigation. So that is so that they can spot anomalies for 1 mark. It means that they can calculate a mean for a 2nd mark, and it also reduces the effect of random error for the 3rd mark. Question 2. The picture shows solid ice on a car rear window. The glass window contains a heating element. There is an electric current in the heating element which causes the solid ice to melt. Part A. Use the particle model to describe how the arrangement of the water particles changes as the ice melts. In other words, as we go from being a solid to being a liquid, and they've included a diagram to support our answers as well. You should include a description of how the particles are arranged in the solid ice and in the water. So, because it's told us to include a description of how the particles are arranged in the solid, I thought that would be a good place to start off with. So the 1st mark is for saying that in a solid, the particles are in a regular arrangement. I will then build on that and say that is because there are strong forces of attraction between those particles. So I'm looking at 2 marks there already. In a solid, the particles aren't free to move, and instead the particles vibrate about fixed positions. I've got 3 marks there for describing the particles arranged in a solid. We now need to look at the other things that the question is asking, because it does say how the arrangement of the particles changes as the ice melts. So let's talk about that melting process. As the temperature is increased, the particles are going to vibrate more, and at the melting point, the particles will have enough energy to overcome the forces of attraction between them. We can then say that what happens once it has become a liquid, the particles in a liquid are free to move about, and the particles in a liquid are in an irregular arrangement. I've got more than 6 marking points for you there, so see if you've got at least 6 of those. Any that you've missed you will want to learn so that you can add them to any future answers to this question or similar questions. Part B. A car manufacturer tests different heating elements by measuring how long it takes for the ice to melt. During the test, some variables must be controlled. Identify 2 control variables in the manufacturer's test. Tick 2 boxes. So we've been told that they're testing different heating elements by measuring how long it takes for the ice to melt. So, because we can see the time taken for the ice to melt as an option, that can't be a control variable because that's what they are measuring. That is the dependent variable. So we can instantly rule out the time taken for the ice to melt. We can then consider the other ones. So the colour of the car, is that going to affect how long it is going to take for the heating element to work? Absolutely not. The colour of the car is irrelevant. The current in the heating element, though, will have an effect because the stronger the current, the more heating the element is going to do. So the current in the heating element would have to be kept the same if we're testing different heating elements. And then the mass of ice, well, it doesn't take long to melt a small amount of ice, but it takes ages to melt a lot of ice. And so the mass of ice is also going to have to be a control variable. Part C. Some of the energy supplied by the heater causes the ice to melt without the temperature of the ice increasing. What is the name of this energy supplied to the ice by the heater? That is, of course, the latent heat of fusion. Part D. When the heater is supplied with 120 joules of energy each second, the internal energy of the ice is increased by 36 joules each second. We've been asked to calculate the efficiency of the heater. Now kindly, they've actually given us the equation. This is an equation that you do need to learn for the exam, but on this particular question they've been kind enough to provide us with the equation. Now all we need to do is substitute the numbers in. The output energy transfer is going to be 36 joules because that is what is being provided to the internal energy store that we're trying to raise. So we'll be doing 36 divided by the input energy, and it's being provided with 120 joules, so the input energy is 120. So we do 36 divided by 120. That is one method mark. The second mark is for the final answer, which is 0.3. So you would write 0.3 on the answer line. The examiner would accept you to convert that to a percentage if you wanted to, which would be 30%. If you've included a unit on the efficiency line, though, you would lose a mark because efficiency does not have a unit. Question 3. Compare the processes of evaporation and boiling. So we've looked at this already in today's lesson. The first mark is for stating that evaporation happens at the surface of a liquid, but boiling happens throughout a liquid. The second mark is for stating that evaporation is a much slower process than boiling. And then the final mark is for saying that evaporation can happen at any temperature, but boiling only happens at the boiling point.